All right, so hopefully you guys have joined by now. Sorry if you had any technical difficulties, but let's get started. All right, we got one more participant in there. All right, so let's begin. So these questions are going to be most about classes, but we will tie in CSV files at some point. All right, so hopefully you guys can see the code snippet well on your screens. But the question here is which variable in this code snippet is an example of an instance variable? So there's 4 variables that I have created. We have an A variable, a B variable, a C variable, and a D variable. So we're asking which one is an instance variable or instance attribute for other terminology. All right, so get your answers in there. All right, so let's see how you guys did. All right, so I think I threw a lot of people out for a loop, so definitely want to discuss this here. So let's actually go to the example. Again, definitely some gotchas in there, but hopefully this one isn't too big of a gotcha. So let's look at, let me code up. Hopefully you guys can see my screen. So I actually have this code up here. So we have 4 variables here, right? We have A up here, we have B within our class, we have C in our init method, and then we have D down here. So the correct answer is actually D, but I totally understand why a lot of you guys picked C. So let's actually talk about all 4 of these variable types, all right? First, we have A, and I assigned that to a value of hungry. This is actually a global variable because it's basically not sitting in any function or any class. It's just sitting out there. So basically, anywhere in this file, I could just use the value of A if I need to. So this is a global variable. Now let's move on to B. B is within my donut class I have created here. I can ignore this warning. I have a variable that's sitting, that's not in any particular function. That's not tied to any instance. This is actually a class attribute or a class variable. And the reason this is a class variable is, again, because this is not tied to any particular instance. So for every donut instance that I create, they will all share this variable, and they're all they're not going to create copies of this variable. A class variable is unique, and only one instance of that variable gets created. So in this case, B is a class variable. It'll be shared by every instance I create of the donut class. If I create 50 of them, they're all sharing the one variable B in this case. So C, which was the popular answer, the gotcha here was I'm assigning it to C in my init method, but notice that I'm not actually storing it on the self. So if I added self here, this would actually become instance attribute. The way I have it right now, C is a local variable here. So let me just type in local variable. So what C is actually doing here is I'm assigning flavor, which I'm passing in as a parameter, and that flavor is being assigned to the value of C. However, that C is actually not being used anywhere, and it's going to get lost once this function completes because it's a local variable, meaning that once the scope goes out, once we go out of scope, the C variable is lost because we've not saved it anywhere. But if you actually want to persist it, we want to actually create an attribute on the self object. We can name it C or name it whatever we want to, and then assign flavor to that. And this would tie it to the instance that I've created, and therefore making it an instance variable as opposed to a local variable the way I had it. All right. So if I did something like C plus equals flavor, this would actually be an instance variable. All right, and then we go down to D. So I actually create a donut instance here, and I create a new attribute on it, but this is an instance attribute because it's only tied to this particular donut. So I assign the value of add sprinkles. So just to maybe clarify this a bit, if I create donut 2 and another donut instance, let's give it vanilla. All right, so now that I have this, if I tried to do something like print out the value of D, print donut D. All right, so if I tried to do something like this, I would actually get an error because donut 2 has no attribute, no instance attribute D. That instance attribute I created for the first instance of donut that I created, so it's only special for that particular instance. Again, that's what an instance variable is. It's specific to each instance. Again, if I wanted every donut instance to have its own instance variable, I would do it in my init method and assign it like such. In this case, C+, again, that's bad naming. I might name it, flavor. So in this case, every instance that I create of the donut will have an individual flavor instance variable. But again, you got to remember to tie it to the self that's passed in for every method, because that self is the actual instance. So to say it another way, I could kind of imagine this being donut, or let's give it a different name just to avoid confusion. So if I name this hello, I can imagine that the self parameter is actually hello when I call, when I create a hello instance. All right, so you can kind of imagine self just being the actual instance that's calling this method. All right, but again, we use self as just convention. So self is just a pointer to the instance that's actually invoking the method. All right, so again, just to be clear, if you don't tie it to self, it's a local variable and it'll go out of scope and basically that data is lost. But if you do self dot and create whatever variable you want, that's an instance variable and it'll persist. So you can use it in different methods within the class, or just use it to print out data or store data to it. So I want to pause there because again, I think a lot of students were thrown off by this question. Again, there's a small gotcha in there. I just want to make sure there's no additional questions about global variables versus class variables versus local variables versus instance variables. Any questions there? What questions do you guys have about instance variables, creating them, where you create them, why you create them in certain places? So maybe to extend this a little bit more, let's create a new method. Let's say this is a method called yummy. Again, these aren't properly named things because I'm not really going to do anything that's yummy related. But if I wanted to create an instance variable here, I totally could. Like I create a new, my new var, I could assign it to something else. I could assign this to, all right, so in this case, I'm creating a brand new instance variable for any instance that calls yummy. So for example, if I called hello and called yummy on it, yummy would actually create this instance variable, and now I would have access to it. So if I wanted to print out something like hello dot new var, again, not the best naming here, but in this case, when I call yummy, I'm calling it with self, like that self parameters automatically pass. I will create a new instance variable, and now I'll have access to that instance variable outside of this function or this class because I've created it on the instance. So my hello instance now has new var. Again, my donut2 has no concept of new var, but if it wanted to, I could call donut2 here and call yummy, and this would actually create that instance variable. So again, a question that you guys might have is why do we sometimes create instance variables in the init method, and why do we sometimes maybe create it in other methods or even just like outside of the class entirely? And that's, again, it comes down to a design decision and kind of what your application needs to do. Typically, you do want to create your instance variables in your init method because that will guarantee that that instance variable exists anytime you need to use it. As opposed to in this example where I create new var in my yummy function, that's not guaranteed to be called. So if I did something like I never called yummy and I tried to print hello.new var before ever calling this function, I'm going to get an error because that new var never got created because I never called yummy. So to kind of avert these situations, generally speaking, you want to create all your instance variables in your init method. Again, that's not a 100% rule. Kind of depends on your case. I mean, again, you can create stuff outside of your init method. So if I wanted to print out my d value, I could just do hello.d. And this is totally valid because I created that instance variable here. All right, so let me pause one last time and kind of just open it up. What questions do you guys have about instance variables or class variables or global variables or local variables? Any variable related question. Now is your chance to ask. All right, hopefully you guys are variable experts now. Let's move on to the next question. Next question. All right, so I've created 3 stub classes. These don't have any definitions, but by the name, you can kind of assume what the object is going to be. So I have a dessert class, a frosting class, and a donut class. My question to you guys is, what's the most proper relationship for these classes when we talk about inheritance and composition and just like how we associate these classes with one another? Let me actually pause the timer. I'll give you guys a few more seconds to get your answers in. Again, kind of conceptually think about what these real world objects would be and kind of how they relate to one another. So we have, again, a dessert class, a frosting class, and a donut class. So I'll give you guys maybe 10 more seconds to get your answers in, and then we'll see how you guys did. All right, maybe 5 more seconds, get your guesses in. If you're not sure, take your best guess attempt at it, and we'll review. All right, last chance, gonna end the question here. All right, let's see how you guys did. All right, good job. So the majority, or I guess the plurality of you guys got the correct answer, which was answer C. So we'll talk about them. It's kind of hard to see all the answers here because there's a lot of text. But yeah, I guess some of you were thrown off, but let's talk about all the, I guess, possible answers and or why answer C is the most proper relationship for this. Again, you could have different relationships and still get your application to work. It's more about designing it properly. And this is, again, goes back to the open-ended challenges we might give you. There might be many ways to kind of configure your classes together, but you got to take a step back and kind of conceptually think about what makes the most sense to represent your data. So apologies if you guys can't see the text. So let me bring up the classes that I had. I think it's up here. Sorry. All right. So I have these empty functions that don't do anything. But let's actually kind of modify these to kind of get to the answer that the question was asking for. So we have 3 concepts here. We have a concept of dessert, we have a concept of frosting, and a concept of donut. So if I kind of think about these again in the real world, the main differentiation feature between using inheritance and composition, I always tie back to is a relationship or has a relationship. So basically, if you're trying to compare 2 things, would you say that one is a type of another thing, or would you say one has a type of another thing? So again, maybe I didn't phrase that the best, but let me actually use my examples. So in this case, I'm going to look at donut, which is, I guess, my main focus here because I'm thinking about donuts. So I'm thinking about donuts here. Sorry. All right. So a donut is a type of dessert, right? So in this case, this is where I would use inheritance. So to inherit the properties of dessert, I would use parentheses and pass that to my class when I'm defining it or declaring it here. So again, dessert could have properties in it. For example, let's say it has a general property of taste equals sweet. Again, maybe not all desserts are sweet, but in general, I'll just say taste equals sweet. So now that I inherit from dessert, donut, now every instance of donut will have an attribute of taste. So if I created a donut instance like such, donut, I don't have any parameters I need to pass in, but I could print out d.taste. And the reason I could access that taste variable is because I'm inheriting it from my dessert now that I've set up my class structure as such. So everything that dessert has access to, donut has access to also. So if I created more class variables or instance variables, that my instance of donut will have access to all those variables, potentially. Again, I got to make sure that my dessert is initiated correctly. All right. So now that I think about frosting and donuts, so donuts generally have frosting on them. They don't always have to, but that's something that I would say is has a relationship, not a is a relationship. So just to clarify, a donut is not a type of frosting, nor is a frosting a type of donut. They're both separate objects that kind of relate to each other. And this is where we use composition. So just to define composition again, I'm going to create an init method. And my def. And this will take in self. Always remember that self. And this will be, let's say, topping or frost. Let's keep it topping just to keep the names a little separate. All right, so I have a topping that I'm going to pass in. In this case, I'm going to store that topping in an instance attribute, and that'll be my topping here. So in this case, donut now needs a parameter. So I would create a frosting object. So I could do it like this. But if I didn't want to nest it, again, if I want to kind of keep it separate, I could just create my frosting instance on line 10. So let's move that down. Frosting. So whatever this frosting might be, let's say it takes in like, it could be chocolate, it could be vanilla. I'm not going to actually go through creating that, but I don't want to take too long on this example. But yeah, I create a frosting object, and then I pass that frosting object to my donut instance. So now that that'll be my topping, is the frosting that I'm passing in, and that's an instance attribute that I created and saved. Again, the reason for this is because donuts have frosting on them usually. They don't always have to, so I could pass in none here also if I just didn't want a donut with frosting on it. But again, the key takeaway is donuts and frostings aren't related through inheritance, as in frosting is not a type of donut, a donut is not a type of frosting, therefore you would not want to use frosting. So this is not what you want to do here, right? So this would be inheriting frosting properties, which still could work for your needs, but that's not a proper design in the way that frosting and donut are related. All right, and then if we can kind of see the other answers. So answer A was donut inherits from dessert and frosting. So in this case, that was the example I talked about that could work, but that's not a proper relationship. Again, donut is not a type of frosting, therefore you don't want to inherit from frosting for donut. All right, the second answer B was donut and frosting both inherit from dessert. So this was maybe asking, hey, would you do something like this? So I guess hopefully I didn't, like, English didn't throw you guys there. Like, I guess frosting, technically you can just eat it by itself as a dessert. I guess that's not what I was going for, so apologies if that threw you guys. But yeah, in this case, you know, frosting is a separate, it's like a subcomponent of elements. Like you could have frosting on cake also. So for example, if I create a cake class like this, and that's also inherited from dessert because they're both desserts, I could have, you know, kind of the same constructor here, and also passing frosting to there. So that's actually kind of highlighting, I'm going to get rid of this inheritance, highlighting the reusability of classes. Like frosting, this same frosting object can be used for your donut class and your cake class, because they both are objects that typically have frosting. So that's why you might break out frosting into a separate class instead of just having it as like a string member, for example. But anyway, so that's why answer B is not correct. Again, frosting and donuts aren't, frosting is not a type of dessert, is the main takeaway there. Answer C, which was the correct answer, which we talked about, donut should inherit from dessert because donut is a type of dessert. It's a specialized type of dessert. So again, when you're creating your class structures, your base classes should be generic. So dessert is kind of like a generic category of foods, and donuts are a more specific type of dessert. So if you wanted to make that hierarchy or that inheritance even further, you could create like special donuts. Like let's say jelly-filled donut might be an extension of your base donut class because it's an even more specialized version of a generic donut, right? So that's another example of how you might structure classes. The last answer, donut inherits from frosting, and then frosting inherits from donut. So this was asking, would you do something like this? So donut, and then you'd have to switch this ordering because donut needs to be defined first. But yeah, if I had something like this, this wouldn't make too much sense because going back to the fact that, again, frosting is not a type of donut. So, you know, this would be an example of multi-level inheritance where you have dessert, donut inherits from dessert, and then frosting inherits from donut. Again, this isn't a proper relationship because of the relationship between frosting and donut is a relationship. It's a has a relationship, as in a donut has frosting. All right, so hopefully you guys kind of understand inheritance composition. Let me pause. What questions do you guys have about inheritance, composition, generally just creating class structures? Again, this goes back to the open-ended questions where we give you challenges where we don't really guide you too much. You guys are going to get better practice with creating proper relationships between classes that you created.
Can I ask a clarifying question?
Sure.
So you said it is possible to pass frosting to the donut class and use aspects of frosting in donut, but it's not good design? Correct.
Yes. So to clarify what Jacob's asking about, or what I went over a bit earlier, for example, let's say I had frosting and made that in here, and let's get rid of this because that's not what we want. And let's say, for example, I did have an instance variable here. Let's just say flavor. Flavor. Sorry, I'm kind of butchering this. All right, so in this case, I might call super units and pass a flavor. Again, maybe my caller wants to pass, or maybe all my donuts have chocolate as their flavor. All right, so in this case, the super will call base methods and then pass in a flavor, but this might not work because dessert doesn't take in anything, so I might actually do something like, specify that I want frosting here and self. Okay, so in this case, I'll call the frosting init method, passing chocolate, and then chocolate will be stored there. So now if I had a donut instance, which I do down here, I could do something like, sorry, I'm kind of all over the place here. I could print out d.flavor, and this would work because I inherited this property, so I have access to this. So just to be clear, this will work, but it's not a proper relationship because donut is not a type of frosting. So this would produce, I'd be able to print out or access my frosting flavor if I stored it like such, because I'm calling my init method on my frosting class, storing chocolate as the frosting for that. This works, so I still have that property, frosting flavor that I'm inheriting, but I necessarily don't want to do it this way. I'd rather do something like self.topping, and then that self.topping could access frosting flavor, assuming topping is a frosting object. Sorry, I don't know if that confused people more than helped. But yes, you can get it to work. It's more about proper design, not functionality. Functionality, it still functionally work, but design-wise, you'd have to reassess what you're doing potentially. But again, you guys are architects, so if there's a particular reason you need to, use inheritance in that case, you can make an argument for it. No one's going to tell you 100% of the time it's wrong, but generally speaking, based on the concepts of dessert, frosting, and donut, donuts and frosting should be a composition, meaning they have a hazard relationship. Jacob, does that answer your question? Did I confuse you more? I think you might be muted.
In line 19, we pass frosting.
Yep.
But where is that defined?
So sorry, I'm talking about topping here, so let me just change this for clarity then. I'm passing in a frosting object. In this case, I could pass that, sorry. Since we changed our hierarchy, now that we're inheriting from frosting here, I could pass in like a flavor. So I'd say vanilla if I want to. And that vanilla is actually going to be directed to the frosting flavor. So I'd pass frosting here. Does that make sense? Again, I'm going through a couple different examples. So when I'm inheriting something, I don't need to pass in a frosting object to my donut. I just specify the parameter that frosting is going to need. In this case, I would pass in a, just all of this flavor. All right. So in this case, I would pass in just one of my property for the frosting flavor, which this would be, and then I would pass that to my init method for frosting, because that's actually what's storing the flavor of the frosting. Still confused? Again, I apologize if I explained that poorly.
So when line 17 prints, it'll print vanilla.
Yeah, so if I put a print statement here on line 16, print, yep, because again, this frosting flavor attribute comes from my frosting class, because again, we're using multiple inheritance here. So donut both gets to inherit everything that the dessert class has to offer. In this case, it just has this one taste variable, and everything that the frosting class offers, donut has access to it. So yeah, we could do d.frosting flavor in this case, because we properly initialize our frosting class, and we could also do d.taste because that's coming from our dessert. Again, that's inheritance is just saying, hey, here, you can have everything that I have. So in this case, dessert and frosting are both saying, hey, everything that I have access to, donut, you can have access to it also if you want it. But if donut, wants to implement its own variables over that, it can do that also. That's overriding. Again, going back to the lecture from inheritance.
Okay, thank you.
Yep. All right. Thanks for asking questions. No, keep your questions coming. If there's any confusion, definitely want to clear it up here. Yeah. So that's again, kind of class design, how you should associate things. Don't inherit frosting. Generally speaking, it should be a member, like such. Frosting. All right, so just to clean this up, to get back at where I wanted to design it, if I had frosting here, I would create an instance of frosting. Frosting, in this case, I need to pass in something, so say vanilla. That's going to be my frosting flavor. That gets saved in my frosting class, and then I would actually pass that frosting object to my donut class, because I want to store everything that frosting has. Again, I could have like 20 different variables here. Like I could have frosting flavor, frosting color, frosting like texture. I don't know what frosting properties have, but again, first, just for the simple example, I have one property, but again, there could be multiple properties that frosting is passing down, or that frosting has to offer me for my donut. All right, let's get to the next question. I think we have a couple more. All right, more about classes. Definitely look out for gotchas. There might be gotchas, but what do you think the expected output would be for this snippet of code? So I have two classes. I have, oh, sorry, I think I put the wrong image. Sorry. Let me fix that. All right, so the snippet should look something like that.
Can you pause it real quick?
Yes. Sorry, that is technical error on my part. The classes should look like this. We have a donut class and a deluxe donut class. And the question is, what is the expected output from this code snippet? So ignore the image that I attached there. I apologize for that. But definitely take the time you need here. So again, I have a donut class, a deluxe donut class that inherits from my donut class. And then I have some instance attributes that I create. So I have a flavor attribute in my donut class, and then an added flavor for my deluxe donut class. These are instance attributes. I create an instance of deluxe donut, and then I'm trying to print out added flavor and flavor. So my question is, what is the expected output? Again, notice we also have some default parameters here. So hopefully you guys remember how default parameters might work. All right, we'll take maybe another 10 or 15 seconds. Again, apologies for the incorrect image there. I'll have to fix that later. But again, we have a donut class, a deluxe donut class that inherits from donut. We have a couple instance attributes. We have some default parameters, and we also create an instance. So a lot going on here. Definitely take time to parse it. And let's say another 10 seconds, get your answers in, and then we'll talk about this snippet of code. So again, the question is asking, what are these two lines on line 11 and line 12 going to print out? We access d.addedFlavor. I want to print that value out, and then d.flavor. We want to print that out. All right, I'm going to save 5 more seconds there, and I'm going to call for answers. All right, take your best guess, and let me end the question here. All right, so hopefully you guys weren't thrown out by the gotcha in there, but if you guys were, it's all about learning from it. All right, so totally understandable. So a lot of you guys put answer A, which was lemon and vanilla. That I definitely understand why that would be the tempting answer, but this is a case where a gotcha might have gotten you. So the correct answer is lemon, and actually the second output would cause an error. And let's actually talk about that and how we can modify our code to resolve that error. So answer A is definitely the tempting correct answer, but in this case, it's answer C. Let's talk about it. So we do have inheritance going on here. So donut is basically giving everything that donut has, deluxe donut should have access to, but there's a key line missing here. All right, so if we think about what's happening, we instantiate or we create a deluxe donut object and pass in lemon as our flavor parameter. So in this case, our default parameter is chocolate, but we actually replace that with lemon because we're actually specifying that we want that flavor to be lemon. Hypothetically, if I did not specify a flavor here, this would still work. But in this case, flavor would default to chocolate. Since I have not specified what flavor I want from where I'm calling or creating this object, it'll default to chocolate. But in this case, I do want to specify the flavor. So in this case, I will set flavor equal to lemon. All right, so this is my deluxe donut. This init method is getting triggered. However, the key issue here is I never call my donut init method. And again, this might not be something that's fully clear to you guys that, init does magically get called when you create an object, but only for the object that you're creating. So in this case, I'm creating deluxe donut. I'm never calling the init method for donut. So if I wanted to resolve this, the key line I would need to add would be I'd call super, which is again contacting the base class, and I'd call init on that. So in this case, I could pass the same flavor in. So I could pass in flavor. So in this case, if I change it to this, my output would be lemon and lemon because I'm using the same flavor. But for example, let's say I didn't pass in flavor there. I just left it blank. This is, again, the same kind of situation I was talking about earlier, where I don't pass in a parameter to this function or this method. Therefore, my flavor would default to vanilla in that case, where I don't specify anything here in the init method call. So my flavor would be vanilla in this case, and my added flavor would be lemon, because that's what I'm passing in for my flavor, my init method here. All right, so again, definitely understand why answer A was the popular answer, because base class does have a flavor, and we do assign it to vanilla if there's no value passed in, but we still need to call our init method. So the code snippet I had above, or sorry, before for the problem, did not have this line in it. So without this line being in here, this block of code never gets called, and therefore this flavor instance attribute never gets created. Again, going back to our discussion from earlier, this instance attribute needs to be created before we can access it. So on line 13, when we call d.flavor, we'll actually get an error. So actually, just do an action, just make sure that I'm not lying to you guys. Let's run this file. So this is Python test.py. All right, so we print out lemon, which was our added flavor, but then I got a attribute error for the second time I tried to print out. And as you can see, it says deluxe donut object has no attribute flavor. That's because this flavor instance attribute never got created because I never called the init method from the deluxe donut init method. So if I actually add this comment line of code back in, now super is referencing my base class. In this case, it's donut. And then init is calling this function without any parameters. So in this case, flavor is going to default to vanilla. And therefore, flavor will be saved to a new instance attribute called flavor. And therefore, line 13 now should print out vanilla. All right, so we get lemon, because that's our added flavor that we store on line 8 over here. And then we get vanilla, because that's our default parameter from our donut init method that gets stored on line 3. Again, kind of tricky there, but again, I want you to watch out for these. Again, understand that you need to call the init method on your base class if you want stuff to happen. Again, if I didn't care about this flavor, then I could totally leave this off. But then I gotta be mindful that .flavor is not an attribute for my deluxe donut. It only exists for a base donut. So if I had something like donut, in this case, A would have access to A.flavor. This would be valid. Sorry. And then this would not be valid. So just to differentiate, I have another instance, but this is just a simple donut. This is not a deluxe donut. So in this case, my init method will automatically be called by this creation. So flavor will get default to vanilla and saved as an instance attribute. Therefore, A.flavor is a valid parameter or a valid variable. But in this case, A.added flavor is not valid because this is not a deluxe donut. Therefore, this instance attribute never exists, and like donut has no concept of added flavor because it never got created.
So if you wanted to pass in a flavor to the donut on line 13, would you just pass it a second parameter?
Yeah, like let's say, yeah.
And that transfers over to the deluxe class, or
Yep.
I'm sorry, the donut class
Yep,
flavor?
you're right. Yeah, so if I wanted to specify 2 distinct flavors, so let's say make a lemon and lime. I've never had a lemon and lime donut, so that sounds actually kind of tempting now. In this case, I would specify a parameter. So in this case, let's say flavor and added, sorry, like this flavor, and this can be added flavor. So again, got to give it different names. If I want default parameters on one, I got to give it on the other. So in this case, I'll just have it glaze. All right, so in this case, I'm passing in 2 flavors, and now I could kind of specify which parameter actually gets which value. So in this case, I would call super, not self. Again, super is just referencing the base class. In this case, I could pass in flavor here, and then added flavor can be here. So in this case, my first flavor will be tied to my donut class, and that'll be a glaze. I don't know if that's actually a flavor, but then my added flavor will be chocolate for my deluxe donut. So instead of having 1 flavor, I have 2 flavors because I'm passing in 2 distinct parameters and saving that 1 on my deluxe donut and then 1 in my base donut class. Again, if I specify lemon lime, I would have a lemon lime donut. In this case, lemon is my added flavor, so that'll go here if I type that correctly. And then my lime is my base flavor. So that'll get tied to my donut object. But then if I had this, I'll get lemon lime printed out here. Lemon and lime. All right. So if anyone knows of a lemon lime donut, I would love to know about it. Oh, sorry, go ahead.
My video wasn't on. So is lemon and lime then overriding the flavors that you have written in deluxe donut?
Sort of, yeah. So I guess they're overriding the default values. So again, if I did not specify anything here, these values would default to chocolate and glaze. Again, I could do 1 and 1. Like, let's say I only pass in lemon here and disregard the lime portion of it. In this case, this is totally valid because since these have default values, I don't have to pass those values in. So in this case, lemon is the only thing I'm passing in. That'll go to the first parameter in my list. So in this case, added flavor will be assigned to lemon, not chocolate. So let me just put the comment here. This would be lemon. But my second flavor would just default to glaze. So this would go to glaze. All right. But if I did want to specify it, then if I added lime back in here without typos, this would now be lime. So basically, yeah, it would ignore this and overwrite it with what I want it to be. Again, overwrite with a T, not override with a D. Again, this will go back to the inheritance lecture. Again, very similar concepts, overwriting versus overwriting. Easy to get confused there. Don't expect you guys to always understand the difference, but be aware that there is a difference that exists out there. All right, great questions. Keep them coming.
So if we just went back, sorry, just to clarify again, if we just went back to where Deluxe Donut just was taking in flavor, chocolate, but you had the super method, the super would still print vanilla. It wouldn't print chocolate, correct?
This way, but without a flavor here?
No, yes.
Yes, so if I left off this flavor, basically this parameter is no longer being used, so it exists, but we don't really care about it. Yeah, I don't pass anything to my base. This would default to vanilla in this case, because that's the default value. Since I didn't specify anything, this will be vanilla. However, if this default value did not exist, so if I delete this, now I'll actually get an error, because this is expecting a parameter and it needs a value for it, because there's no default value. So in this case, I'll get an error, because I didn't specify default value, so I get, error when I print this out. If I printed it out. Otherwise, sorry, it'll get an error when I try to call it, because I need to pass in the value. So I would put flavor here.
Perfect. Thanks for clarifying.
No, thanks for asking. Absolutely. Thanks, Kyle.
So super just always refers back to the base class then, right?
Yeah, I'll say for a yes/no answer, I'll say yes. Again, going back to the lecture from inheritance, I don't want to get too into it because you don't have to worry about MRO for the assessment or anything like that. But this will call the next item in the MRO list. Again, that's a little confusing topic. So the simple answer is yes. This will tie back to donut because donut is the base class here. So super is another way to just call donut. I could definitely put donut here and pass in self. This would work also. There's nothing inherently wrong with this, but as we talked about, super is the preferred way to do it because it kind of saves you from trouble with other situations. But yeah, those are equivalents for the most part. Yep, super is just another name for your base class, and we'll call the method that way. You don't need to pass in self if you're using super.
A question for you. This might be like a real tangent example, but if you were to do flavor equals flavor is a keyword attribute in the super call.
Right here?
Yeah, so flavor equals flavor. So then you'd be forcing it to that keyword attribute of the previous class, of the parent class. If you had multiple inheritance, would it go find the one that has flavor if the next one up didn't?
I don't believe so. So super will still try to call this init method. So if I try to pass it, and let's say this was named something else, for example, but then I had another base class, you're saying like this? Here. Let's try it again quickly. I don't want to waste too much time because we definitely want to get to more generic review questions, but let's try it. I am curious. So let's say we had flavor up here, and that's expecting flavor. So I think in this case, it's going to try to call this init method because that is, what super is calling first. And it's going to say, hey, there's no attribute flavor, so it might complain. but I'm curious, so let's quickly give this a run. So do something like this. So in this case, we have a parameter yum that this init method needs, but our base class needs would accept a flavor attribute. So let's give that a run. I think I coded that correctly. Maybe, hopefully. Yeah, so we got an unexpected keyword argument flavor. Because again, this yum still needs to be handled, and it's looking for flavor here and saying we can't find it. But good question. I'm glad you're thinking about additional inheritance situations that might come up. All right, cool. Let's go to our last question, and then we'll open up for view. But hopefully my images are correct here. Okay, so another class question. This is, again, kind of tying into Jeremy's question about maybe named attributes. But which of the following ways is not a valid way to instantiate an instance of the donut class? Again, we have four instances that I'm creating, A, B, C, and D in my code snippet. Which one of those is not a valid way to instantiate a class? So again, there's a few ways that we can instantiate classes. We've kind of talked about them throughout this week. We're going to double back on that through this question. And this is sort of related to CSVs, so that's something that might be beneficial or helpful when you're dealing with CSV data. I'm going to pause it. Looks like I should have longer time limits here, but let's spend another maybe 10 seconds kind of reviewing that code and then trying to figure out which one is not a valid way to instantiate an instance of the donut class. All right, let's say 5 more seconds. Please get your guesses in if you have any guesses. Take your best stab at it. If you narrow it down to 2, maybe guess 50-50. But all right, I'm going to call for answers in 3, 2, 1. All right, ending question. All right, let's see how you guys did here. All right, great job. It seems like a lot of you guys understand which ways you can do it and therefore which way is definitely invalid. Let's talk about it. A few of you guys put C or D. So let's actually talk about what each one of those attempts at instantiating class is doing and why one is correct or one is incorrect and the others are correct. So I think I have that coded up here. Let me bring that up, close my terminal, and yep, down here. All right, so I have a class donut. Ignore the warning. It's just like create the same class again. All right, so there's a few ways. Again, we could create instances of classes. Some are just more beneficial if you're dealing with certain types of data. So in this case, I have I have an array with dictionary elements. So I have like 2 donuts in here. I have something called dark cream, which is a flavor of chocolate, and something called snowstorm, which is a flavor of vanilla. So that's my data, and I'm trying to create an instance in these 4 ways. So let's talk about the first way. Here, this is where we're leveraging something called quargs. Again, this is a funny sounding name, but this is kind of a convenient way in Python where you can kind of break apart a dictionary and assign variables that way. So this is, let's say, quargs automatically. All right, so the way quargs works is basically these variables need to be matched with the keys in this dictionary. So just to break this apart, I have 2 entries. The first entry has a name and a flavor. And again, those need to match the names of the parameters that this function needs to take in. So in this case, my init method is requiring a name value and a flavor value. In this case, since my data matches up with that, I can use quargs, which is the double asterisk operator. That's an unpacking operator. So essentially, it's going to unpack this dictionary and create key value pairs. And we'll talk about that in one of the other examples below. But again, just know that if you have a dictionary and you want to just quickly assign it to a class, if you have the proper keys, you can just use the unpacking operator and it'll kind of just magically assign the right values to the right variables. Again, even if these values were out of order, for example, if I have something like this, let's say I have my flavor first, my name second, this would still work. Option A would still work because, again, these are associated by name, not by order. So the ordering of my parameters doesn't really matter when I'm using quargs. Again, quarg stands for keyword arguments. So again, the double asterisk is an automatic way to kind of handle that when you have dictionaries. All right, so let's look at B. So let me space it out here. We have B here. This is actually doing something that I'm not even sure what it's trying to accomplish, but this was the correct answer in that you can't really do it this way. So in this case, if I look at my data, index 0 is my first dictionary item, and then I'm copying it, but this wouldn't work. This would work for arrays, not for dictionaries. So I don't think this would produce anything valid. This might produce a dictionary. I guess I'm a little hazy on that, slicing dictionaries if that's even possible. But yeah, this is not going to give me a name value. It's going to give me something that either doesn't work or is something that I can't just assign to name as I would want it. Same thing. So then we have data one. This is actually access the second donut object. So again, we want to create one donut from the data, but in this case, we're accessing the second donut data that we have. So again, that hopefully led you to like look at it and be like, all right, why are we accessing two different data objects for one particular donut? So again, this is kind of nonsensical in terms of we have dictionaries. I don't think you can slice them. But yeah, so B was the correct answer in that it is not a way you can instantiate a donut object in this case. So let's get down into C and D. So this is again going back to keyword arguments. That's D, I guess. So in this case, this is wrong. Okay, let's look at C. So this is probably the typical way we're used to assigning or calling a function. We have to have the correct order. So in this case, I'm accessing my first donut data, which is a dictionary. So I access the name component via the square brackets and name. So that's the key in my dictionary. And then flavor is my second attribute that I'm extracting from my dictionary. Again, these are both on the first object in my dictionary, or sorry, in my array. So that's what data is at 0. I'm focusing on the first element, which is a dictionary, and I'm extracting the name and flavor via the keys. So in this case, the order does matter because I need to pass the name in first and flavor in second, because that's just the structure of this. Again, I'm passing in two parameters that have no name associations, so the order does matter. If I swap these, I'll get the wrong data. Like it might still work because they're both strings, but I'm not going to have proper name and flavor stored in there. They're going to be swapped because I just swapped the order. All right, so it's option C. That's a valid way to do it. Also, you just pass in the parameters as they are listed in order, and that'll work just fine. And let's go to option D. So this is another example of quark. So let me just say this is ordered params without typos, hopefully. And the last one is another instance of quark. So hopefully you guys kind of understand what quarks are and kind of how to use them, but this is manually. So in this case, we're assigning the parameters that we're passing in to a keyword name. So again, this name that I have here matches the parameter that I'm passing it to. So again, the order here is swapped. So I have flavor first and name second, but this is fine because I've specified that, hey, the flavor parameter of the method I'm calling should get this value. The order here does not matter. So quarks, again, just kind of saves you from having to know the particular order. Like, especially if I had like 20 different parameters I need to pass in, it's pretty easy to kind of like swap one and not even notice it, right? So if you have them associated with the keyword, then you can just pass them in any order you want and it'll match it up correctly. The method would automatically match them up correctly because it knows that, hey, this data that I'm passing in is attributed to the flavor parameter. So this will get the correct value. And likewise, name, since I've specified name equals, and then give it the value, they'll find it correctly in the parameter list. Again, that's another instance of quarks. So that's kind of manually doing it versus if you had a dictionary, you could use the unpacking operator and it does the same thing. So basically, if I unpack this, I'm going to get the same output here. As in, I guess, option A and option D, the unpacking is basically just doing this magically for me. Was there a question out there?
So with line C, or not line C, but C, would it work with the first dictionary or no?
Sorry, could you say that again?
Line C wouldn't work with the first dictionary where you got like flavor first and name second? Or?
Correct. Yeah, so if I swap these, this would not work. Yeah. So in this case, yes, this would not work. Even though this is swapped, like the dictionary, the order of the dictionary doesn't matter. It's the order that I'm passing in the parameters. So, if I swap these, again, like this doesn't have any impact on what I'm trying to do. So yeah, the ordering in my dictionary doesn't matter. It's the order that I'm passing it into my method that I'm calling. So in this case, name has to be the first parameter. So if I pass in flavor, that's going to get me into trouble because it's the wrong data that I'm assigning it to. Did that clear up your question or did I misunderstand it?
Nope, that's it.
Gotcha. Thanks for asking. All right. So again, quarks, just a convenient way. Again, you don't have to use them, but they will definitely save your save you some time, especially if you're dealing with CSV data, which we'll cover shortly. All right, one last question, and then we could kind of wrap up the review. So let's get to it. All right, so assuming I have a donut object, what is a convenient way to kind of extract, convert a class into a dictionary that I could use for like writing out to a CSV, for example, or for whatever else I might want to do. Hopefully you guys are familiar with this. If not, that's kind of why I wanted to have this question in here. But you have 4 options. Again, this is assuming you have a donut object of the donut class. So donut in this case is an instance. Time ran out there, sorry. I gotta extend my time there. All right, so, okay, so I'm glad we had this question here, because again, this is definitely helpful, especially when you're using CSVs and like dictionary writer and reader. So the correct answer was option A, which is the __ dict property of donut. So this is, I guess, an automatic attribute that gets added for every class you created. So if I had like a cake class, that would also have the __ dict _ as a default attribute. So the other methods do not quite work. I mean, you might be tempted to think that you just pass in a class to a dictionary constructor and the dictionary would automatically know how to create the class representation for it. But I tried it, it does not work. It'd be great if it did. There's no toDict method that I know of. So if you try calling toDict on a donut instance, it's going to complain like, hey, toDict is not defined, assuming that you're, that you didn't manually create a toDict method. And then the last one is using list comprehension to try to create something. Again, that's going to create something that's not what you want. Again, that might create a list. That attribute is something I just made up, so I don't think you can use that freely unless you implemented that method yourself. But yeah, the correct answer is just using the __ dict. Let me just kind of convert this into CSVs, because you're going to be using CSVs for the assessment. And again, this is something hopefully you guys are familiar with, but if not, I have something coded up. So just want to go over it in case there's any questions or just you guys want to see another example. So just to walk you through my code, I'm importing CSV because I plan on reading a CSV file and writing to it. Then I create my model. So my model in this case is just a class representation of the data that I'm going to be working with. So again, I have class donut. That takes in 2 parameters. In this case, it's going to be the name of the donut and the price that donut costs. So let's imagine I'm a donut shop owner. I have a donut name and a price for each object that I create. All right, and then here I'm just converting, like if it's a string value, it's going to be converted to a float, so prices are usually reflected in decimal point or floating point. So that's simply what my donut class stores: a donut name and donut price. Then I create an empty list for donuts, which I'm going to store data in. So I have a CSV file that I created called donuts.csv. So if I want to open that up and take a peek at it, again, this has a header. I have donut name and price. And then I have some entries here. I have chocolate glaze that costs $2.50, and then a few others. So my goal here is to read in this data and store it in my as a class representation. So if I go back to my donuts.py, I'm going to use the dictionary reader from CSV, because this makes it kind of easier to deal with data. So again, you don't have to use dictionary reader, but it's usually just easier to do it that way. So in this case, I'm going to use this syntax. So again, hopefully you guys have seen this before. You can type with open and then pass in your file name. So in this case, my file name is donuts.csv. I'm going to specify the flag of R, which means I want to read from it. I think by default, if you don't pass it in, it's going to default to read. But in this case, I want to be explicit. So I'm passing that R that says read. And I'm giving an alias to that file that I'm going to open. So in this case, I name it CSV file. Again, this could be named whatever. So I want to name it whatever, like literally whatever. I could name it whatever. That's fine. But usually you want to name your variables a little more appropriately. So I'm going to just name it CSV file. All right, so then I call CSV dictionary reader, pass in the file that I want to read, and that's going to give me a dictionary reader object. Again, dictionary reader is a class, so we're creating an instance of that dictionary reader by passing in a file. And then finally, I'm going to use a for loop and go through my dictionary reader item by item. So each item in my dictionary reader is a dictionary with the data that I'm extracting from the file. So if I actually printed this out, I would see that each item dictionary has items. One is a name, and then the actual name of the donut, and then one will be the price, and then the actual price that I read from the file. All right, so actually we'll print out that information shortly. But let's talk about line 15. So this is kind of what we just went over, but this is one way you can create a donut instance by using a dictionary. So that's why dictionary reader is kind of handy. I use the unpacking operator, unpack my dictionary. The reason I could do this, just to again reiterate it, since my header names, again, donut name and price match exactly what my parameters are here, donut name and price, I can just unpack it, and then the values will be passed to this correctly. So even if I had these swapped, like if I had price and donut name swapped, this will still work totally fine because I'm using kwargs here. Again, taking a dictionary, unpacking it, and converting it to kwargs or keyword arguments. The ordering here does not matter. All right, so I'm creating a donut object and just appending it to my donut list. And then let's say I want to modify my data in some manner. So in this case, in my example, I just want to change the price of each donut by $1.05. So if I look at my input, again, I have prices $2.50, $2.50, $3, and I have expense one or gold powder. People like gold flakes, apparently that's a thing. So I'm just going to raise each donut by $1.50, regardless of the initial price. All right, so that's the task of my algorithm. And then I'm going to write out to a new file. So I use the same syntax. I use with open, and I'm giving it a new file name. Again, I could write back to the same file if I wanted to, but in this case, I just don't want to overwrite my data. And I use W, which means I want to write out to it. Again, if you used A, that would append to it. So any data that's already in my donuts underscore new file would get appended instead of overwritten. So we kind of see the two differences there. In this case, I want to write out to it. Again, I give an alias, and then I use dictionary writer. So dictionary writer takes in two parameters. One is the file you want to write out to, and then you got to specify the field name, so the header information that you want in your file. So again, if I look at my original file, I have donut name and price, and that's what I'm going to get from my class, because those are the parameter names. So once I have that dictionary writer instance created, one thing to remember, you want to call write header if you actually want those fields printed out. So by default, these are not added to your file. Again, this kind of gets me sometimes, so I assume it'll just magically write it out. But you got to call write header if you actually want, the donut name and price written out. And then finally, I'm going through my donuts list that I created earlier. Again, remember, the donuts list has instances of donuts for my data. And this is the property that I talked about earlier. The underscore dictionary will kind of just auto magically convert your instance members into a dictionary form. So if you want to actually see that, let me print that out, and we'll see what this actually looks like. But again, it's just a dictionary that represents your values in your classes. So if I use that dictionary attribute, I could just use my dictionary writer, pass in that dictionary, and it's going to write that data out as I want it to. So let's actually see this in action. So let me delete this because I want to start with a blank file. And then my input file is what I showed you guys before. So I have donut name as a header and price as a header, and then some values underneath it. All right, so let me give this a quick run just to kind of verify it works. And then that's pretty much all I have to share at this point. So my file is called donuts.py. And of course I get an error. Sorry, on the wrong thing. Donuts.py. All right, so let me bring up my terminal a bit so we can see it. All right, so I got some output. So notice that I'm printing out the names of my donut on line 19. I have donut.printName. And then after that, I'm adding to the price. So again, this is updating my software representation, but I actually want to print this data out. So once I've updated each value by $1.05, my next task is to write it out. So on line 27, I'm printing out the dictionary representation of each donut object. That's what you see here. You see donut name and chocolate glaze with a price. Again, these are all classes that actually I'm calling the underscore dict property or attribute, and that's going to convert it to a dictionary essentially. All right, and then on line 28, I'm actually writing that out to my file. And let's look at our new file, make sure it looks right. Sorry, here's my new file. Let me split screen it with my old file. All right, so this was my old file. This was my input. I had prices and names. As you can see, I got the correct names out still. Like I didn't modify anything there. But the prices got increased by $1.05 each time, which is what I wanted. Like that was the task at hand. So again, just to explore what writing versus appending might do. So if I actually change this to an A, this would actually update this file, but add new rows and actually add another header in. So this is again a situation you guys might have been running to where the header was, keeps getting into your data files. The reason might be because you're appending. So if I run this again quickly. All right, so again, I get the output. That doesn't really matter to me. Let's look at my new file and trash this. All right, so in this case, yeah, I got, I got 2 headers. And I got the same data written out because my input never changed. But yeah, so that again, that might be a reason you're seeing the header repeatedly. If you wanted to kind of circumvent that, you can maybe check if you initially had data, then don't write out a header. If your data was initially blank, you write out a header. That may be one way to handle it. So I could do something like, how would I do this? I guess I could try to read in that file and see if there's any data in there. But yeah, it's not always simple to kind of deal with the header correctly. But yeah, so the right header is going to write it out each time I append. So usually we recommend writing because usually you're reading your entire data, you're going to update it and then write it all out. So appending, we don't need you guys to worry about that too much. Unless you're like maybe adding one student and you don't want to read it in your file, you might just append to your existing file. Sorry, not student, donuts. All right, I kind of went a little fast there, so I definitely want to pause, make sure I didn't lose anybody. So what questions do you guys have about opening a CSV file, reading from it, creating class objects from that data using quartz, and then modifying data? I think we're all pretty familiar with that. And then the last part is writing out to the CSV file by using the __ dicts and the dictionary writer from CSV.
Hey, Ankur, what happens if you write row without the dunder dict?
Good question. Let's find out. I'm pretty sure this would cause an error because I think write row expects a dictionary object. And in this case, I'm passing a class, an instance of a class, so it doesn't really know how to handle that class. But again, always worth trying. So we can run this quickly. Yep, so I get an error. Again, it's kind of messy to see here because I have other output. But I get an error saying donut object has no attribute keys. So again, it's expecting a dictionary because it's extracting the keys from it. But yeah, so always worth trying. But yeah, in this case, dictionary writer needs dictionaries because it's kind of what the name implies. But yeah, so again, if you want to get a dictionary from a class, an easy way to do it is use the __ dict property. All right, so CSV files, hopefully you guys are pros at it by now. There will be some question on assessment regarding working with CSV files, so hopefully you're comfortable with it. I could post this somewhere at some point if you guys need a reference point, but hopefully you guys have practice with CSVs enough to be happy with them. Any questions out there? What questions do you guys have about CSVs, about anything we've talked about here?
I found a cool trick for writing the field names out. Instead of having to hard code it, you can take the index 0 of donuts list and then take the .keys method, and that gives you your keys for your field names. Yep, absolutely, Brian. It's a great suggestion. This is something that has bothered me because you don't want to separate your field names from your actual data. So this could be one way you could do it. The only caveat here is that if your donuts is empty, you're going to get an error here. But otherwise, yeah, this kind of ties your field names more directly to your data at hand. So that could be something you can do. Again, this will fail if donuts is empty, but otherwise, this is, I guess, a better way because it's tied to your data. But yep, thanks for that suggestion, Brian. Were there any questions, again, about anything we went over, CSV files, about classes, anything?
Ankur, could you do a quick example of a unit test for CSV?
A unit test for CSV. Okay, good question. I guess I might need a little more clarity, but let's have donuts test. Not donuts, donuts. All right, let's give this a quick try. So I'm going to import unit tests. And that's the first thing I usually do for my unit test files. I'm just going to add in that, that random thing that we always seem to need here. Name equals name. And I've got to just call unit test.main. Again, this is something you have to do. You can read the documentation for why this is required, but just kind of assume you got to do it. All right, so I'm going to create a test case. So we use a class in this case. I'm going to call it donut test cases. Again, this is where we use inheritance. So we're going to inherit from the unit test case class. So this is going to give us everything that test case has access to. Donut test case will have access to also. And then let's create a method. So in this case, I'm going to call tests price of donuts. And yeah, so I'm going to probably have to clean up my code here and create some functions. So let's quickly create a class. So I'll move these actually into my class, since I already have one. So in this case, I'm going to create a method called read donut data, and that's going to be self. I'm going to paste in that code that I just copied. So again, now I have a method on my class that I could call that's going to read in all the donut data. So I guess this might actually be a class attribute, or class method, sorry. Because again, I don't need a particular instance in order to read in my data. That's kind of independent of instances that I create for donut. And then maybe create another class method called this. All right, so to write out my stuff, I'm gonna have that here. All right, so now that I have this class, I can actually create an instance of it and kind of test out reading and writing out from CSVs. So, sorry, write donut data. And then I have my last thing where I actually modify, do some modifications. So let's just say it's going to be an instance method called modify price. And then we'll pass in a self and let's say a value of how much we want to increase.
On the class methods, you have to take off the self, right?
Thank you so much. You are correct. I would lie and say that was a test, but no, I totally forgot that. So thank you, Brian. Always good to have an extra pair of eyes. Again, pair programming, totally recommend it. Class. All right, so this should work. Again, you might want to actually create a separate class to do your reading and writing. Again, maybe for just time's sake, I'm just going to put in my donut class. I don't think it's inherently wrong. It's more about kind of thinking about conceptually. Like maybe you have a donut shop that does the donut data reading, but in this case, I'm just going to keep it simple. So it's going to be single. So I'm going to do self.price is going to increase price by. Again, hopefully you guys are familiar with this notation of plus equals. If you're not, again, this is essentially the same thing as just doing price plus the value and increase of that. And I don't need this here. All right, so I have my class set up, and now I'm going to create a unit test for it. So hopefully I didn't screw anything up here, but quite possible because I often do that. But let's go to my unit test, and where does that go? Test, don't test. All right, so let's actually run a test. In this case, itself. Say test increasing the price of donuts. All right, so Jennifer, you might have to kind of clarify, like, do you want to test the software, or do you actually want to like read the file and see that the correct value is written out?
Yeah, like reading the file that you change. Is there a way to test that the changes were made by?
Sure, yeah, absolutely. Yeah, that might be a little more involved, but we could definitely do that. So in this case, we're going to read in the file. So let's create a donut, which we don't need to. So we're going to call the class and call the class method on it. Donut.read donut data. Obviously, I'm going to have to import my class. Don't forget that. So from donuts, import donuts. All right, so I'm going to call my class method and call read donut data. So that's just going to read out all my data from my file. At this point, like I know what my donuts file has, so I know that the first item is chocolate glaze. So I can kind of take advantage of that for my testing. If I go here, so I'm going to read in all the data, and then I'm going to create an instance of, sorry, I just got to store it somewhere. So this should return donuts. I need donuts stored. All right, so I obviously need a container where I store all my written data, and I pass back donuts once I read the values. So go back to my test, and my donuts will be passed in once I read them all in. So let's look at it.
I got a quick question.
Go for it.
So is the main benefit of class methods that you don't have to like create an instance to, I guess, do whatever the class method is doing?
Yeah, so theoretically, I could have just had a read donut data function in my class instead of tying it to a class, but it's just easier because I can just import it with my donut class and have access to it, as opposed to having a separate function that I gotta import separately. But yeah, so you can totally just have, but yeah, the reason I have a class method is so I don't need an instance. I just want to read in data, which is agnostic of having an instance that exists.
Gotcha.
Yep. But yeah, so it should be a class method, or it could be totally a separate function that's outside my donut class. Those are the two options. Having it be an instance method doesn't make much sense because each instance doesn't need to read the file each time to get all the donuts out of it. But all right, so I have my donuts. Let's say donuts 0 equals something. So price initial equals that. Let's get the price of the first donut again. So this is going to be my chocolate glazed that I want. Sorry, I have too many files open. All right, my chocolate glaze is the item I'm going to read in. And then let's price initial. All right, so then I want to self.assert equal that's price written, price initial. And then, sorry, I'm kind of confusing what I want to test here. So donut 0 dot increase price by. So I probably have a separate test to test that my software is actually increasing the price, but let's assume I have that test case already. So in this case, I'm going to call increase price by and increase by $1.10. All right, so just to you guys walk through what's going on here. So I'm reading all my donut data, getting a list of donuts. For the first donut, I want to increase the price by $1.10. Then I'm going to store the final price that value is, and I'm going to compare that against what I actually write out to my CSV file. In this case, final, or if I wanted to do something a little more fancy, I could do initial equals this. All right, so one test I could have is, again, this is not testing the CSV file directly, but I should definitely make sure that my add method is doing something correctly. So my price final, price initial plus add should equal my price final. All right, so this is one unit test I would definitely want to add if I had my code structure as such. So in this case, I have my initial price. I know how much I'm adding it by. I call a method that should increase the price by the value added, and that should be my final price after that method gets called. And then I should assert that those two values are equal. All right, but if I wanted to test the CSV file, I might do something similar. In this case, instead of checking the price initial versus the price final, I know that my price final should be plus 110. Sorry, it should be my final price. So I don't need my initial here. I'll make this 110. All right, so if I wanted to check my CSV file, I actually read out that new file. So I might need a new method, or I could just do this here. This isn't probably what I want to do, but for time's sake. I'll create another method. Again, this isn't the most code reusability way, but read new donut data, and this is going to take in donut new. This is the old donuts, and I want to read it. All right, so in this case, this is the same exact function, so maybe this could take in a file name and save myself some trouble. Right, so ignore what I just wrote. So basically, this function will take in a file name and read that file and pass back the data from that file. So if I have this now, I could call, what is it, donuts.csv here in this case. And again, the new file that I create is called donuts.new, and that's what I'll compare my data against. So let's call new donuts here. All right, so this is my new donut data that I'm going to read from the file that I just wrote out to. So in this case, that's donuts_new. I get the new donuts data, and I want to compare donuts.0.price plus 1, I guess, let's have initial price. Just copy this back. Copy. All right, so in this case, I'm going to compare donuts, my original price, which is price initial, from my original file that I read in. I'm going to add $1.10 to it, And I want to make sure that that is the output for my new donuts. So in this case, new donuts, the first entry, again, the order is maintained. The price of that should match what I expect it to be. In this case, was the initial price plus 110. So again, hopefully I run this and there won't be issues, but knowing me, I probably had like 20 different typos. So I'll try running it once. If I don't quite get there, I might kind of abandon this because we got to get to the assessment. So let's just run this quickly. Python donuts test py and indentation test.
I think you're missing an S on line 11 too after donut and 19.
Paired programming saves me all the time. All right, thank you guys. Thank you guys. All right, and indentation on line 16. All right, so it looks like I have indentation errors. I apologize for that. I don't want to spend too much time on this because we gotta get to the assessment. So can I wrap up here? Let's wrap up by 10:30. I will kind of tinker with this, but let's use the next 10 minutes wisely. So any last questions, either from something we went over or something that I did not go over that you want to kind of discuss. So kind of going to pause here. What questions do you guys have about this entire week, or even week 2? If there's some material that you think you still want to go over, we can talk about it.
I was just gonna ask really quick. I was having like an error last night when I was trying to import. I was saying like module not found, and I was trying to like do a little bit of research and stuff, and just smaller errors. See if you can clarify. Gotcha.
So module not found is usually you're just not specifying the file path correctly. So if I wanted to maybe show a quick example of that, let me just say my my source file, and then if I move my donuts.py into that. So in this case, since I moved it into a folder, when I import it, I need to add that source ahead of my module name. So in this case, it's going to look in the source folder and then look for a file named donuts. So again, if you're getting module not found errors, that's again, it's 99.9% of the case you did something wrong with the importing in terms of you didn't specify it correctly. If these were in the same files, I would need that dot still, potentially. So I guess I'm a little confusing myself here, but if I had these together, these would still need that dot if something outside this folder was calling both of these files. I believe this dot is required, otherwise you'll get module not found errors.
So a lot of the errors, if you're trying to the file you're executing is located in the same directory, all you need is like from the file name or import, from the file name, import whatever class or whatever function you want. However, if the file you're executing from, if you have, disregard everything. I just, so yeah, I'm just trying to look at. So for example, for your runner file in like school interface, if you're running your runner file and you're getting module not found, the issue is exactly what Ankur just said. You need to specify the directory as well as the file. However, if you specify the file or the directory and the file, and you're trying to execute that, if you're trying to execute that file from within the same directory, you don't need the file or the directory name. So if you would just need donuts, import donut, from donuts, import donut.
So Tom, just one question, maybe you might have a better answer. So sometimes the dot is needed here. And is this because if you're calling from outside the folder, even though that both these files might be in the same folder, the dot is required? Is that correct?
I've never encountered that before, but.
Okay. I think I've seen that, but again, if you do happen to run into issues where you import it, both these are in the same folder. I think if something external to that folder is calling these files, you might need the dot there. So just be aware of that. I've run into that issue, so I think that dot might be required, again, if they're in the same folder, but something outside's calling it. All right, any last questions before we take a quick break and then get you guys assessments? Or maybe we'll just give you guys assessments, you get to take a break if you guys want it. All right, so I'm filling my test cases, so obviously did something wrong. List out of range, that's not good. Donuts. All right, any last questions? Do you guys actually want me to post this donuts example? I don't know if that's helpful or just gonna distract you thinking about donuts too often instead of this.
Yeah, could you post it, please?
Sure, I'll post it somewhere. I'll post in November's chat eventually. Yeah, just look out for that if you actually want to look at it. My test cases need some work, so I might kind of work on that while you guys are working on assessments. But other than that, I'm going to pause for final last questions. Otherwise, we'll hand you guys assessments and wish you guys best of luck. Again, I think you guys should be prepared for it. I think Tom or Chad made this comment. I'll kind of reiterate it. Assessment 2 is maybe actually like less difficult than assessment 1 in terms of assessment 1 was very algo heavy, as you had to kind of figure out an algorithm yourself. This assessment, it's more about working with classes and CSV files and just understanding how to use those correctly. The algorithm isn't as algo heavy, so maybe less stressful in that sense if the algorithm part was difficult for you guys.
Would it help if we commented throughout our code just for like the instructors when they read our assessment?
Absolutely, yeah. So I might have mentioned this to a few people, but I will say comments are optional, but we also are kind of grading on code style and code cleanliness. So comments definitely add to your code style. And then I also mentioned to my discussion group that, you know, if you comment your code correctly, and then like I or Tom or Chad is reviewing your code, even if your code is not working correctly, if you have a proper comment saying, hey, this is what I intended to do, like we can get into your mindset, you know, we might give you extra partial points because we know that your thought process was correct, maybe your implementation was incorrect. Rather, if you just have a bunch of code that doesn't work, we might not be able to figure out what you were trying to do, and therefore might, you know, give you a lower score just because like it doesn't make sense that we didn't know what you're trying to do with your code. So yes, comments highly recommended if you have time for it. Again, they only take like, you know, a few seconds to add in there while you're coding. And also you should be pseudocoding, so comments should kind of be there already for you if you're pseudocoding properly. So yes, the comments, definitely would love to see them. We're not gonna, you know, we're not gonna fail you if you don't have comments in your code, but definitely recommend them.